Well, just a preamble. This is being recorded, so if you have a question, raise your hand. I'll point at you, and then a microphone will be delivered to you. Please say who you are, your affiliation if appropriate, and then ask your question. So, any questions? First one there, sir. Just mic's on its way.
Thank you. Very interesting talk. You got your position from one satellite. If the plane had been flying east or west, it would have handed over to a second satellite. Could you have pinged the plane from a second satellite and therefore got two position lines?
Obviously, we checked our logs to see if that terminal had logged onto any other aircraft, and it hadn't. It was obviously flown in from somewhere else. Previously, it was in the logs for a different ground station or different satellite at an earlier time, but not during the flight itself. Unfortunately, that would have been great help, having two arcs to intersect, but no, we didn't. We only had messages from the Perth ground station over the IOR satellite.
Over there.
Paul Sladen, 19-inch networks. In order to know where something is relative to the spacecraft, this is tracking telemetry, in order to know where something is relative to the spacecraft, you have to know where the spacecraft is. The orbit before was stable and the orbit after was stable, but on the day of the 7th of March, there was a orbital station-keeping burn, which produces uncertainties, transient uncertainties. What was done to rerun the numbers or recheck the numbers after that burn, and when does it stabilise?
Well, the burn was done 24 hours previously. So, and the orbit propagation software is about 80-second burn, east-west 80-second burn, perturbates the orbit almost nothing. And the ECF files generated by the flight dynamics software automatically incorporates the burn prediction. And we've been flying this satellite for almost 20 years. The burns are well known, and the orbit difference is absolutely minute. In terms of the relative motion, almost negligible. It's a very small burn.
Since you released your data on May 27th, there was a lot of experts who tried to do the same work than you. First of all, one of the questions is, a lot of data were missing on the data you released on May 27th. A lot of lines were deleted for any reason. And those experts tried to do the same jobs, but came up with different conclusions, more south, west, more or less. So did you look at it? So did you answer those guys? This is my first questions. And also, is it possible that you make publicly all those datas, which would be unredacted? This is the first question. The second question is, there was also in the search has been shifted again far more south-west the last month after you release your data. And this seems that was done with satellite communication from phone communication from the ground and not anymore from your datas. And the last month, again, the search area was changed to more soft area. So did you use those data also to change your calculations? Did it change anything to you? And at the end, if it changed anything, what did you change? Did you change any hypothesis, or did you change your new area?
Lots of questions there. So let me start at the beginning. No lines were missing from the data released. Every entry, some records within the individual lines were removed for readability because the log is huge, but all the lines are present from 1600 onwards. So no data is missing in terms of time, what information, what message was sent, and BTO and BFO values. So all the analysis presented here is and can be done by anyone who wants to do it. The information is there, so I don't think it's true to say that the information is not present. In terms of the, you made reference to the phone call. That is a phone call in those logs. So it was a ground-to-air call, unanswered, in the Inmarsat log. So it's already available there. And the Doppler on those measurements, they use different channels. So the initial analysis was done using the same channels that was available on the aircraft on the ground. And once it was these R channel messages, also C channel messages used for the calls, that's available in the logs that's been released. and it was understanding the Doppler associated with that. In terms of moving search area, that's really for the ATSB to say it's there. We're only an advisor to them as part of the overall team. But I think it's the point has come is that there's been a refinement in analysis. I mentioned the AFC correction. That's made a few hertz change, but a few hertz change makes a difference in terms of search area. And that's really where the predicted time to be slightly earlier for the turn south related to this call, and also for the refinement in the AFC calculation, which I think we've now got nailed. You can see you've got nailed pretty accurately with the component from the satellite. So I'm not sure there is any.
Okay, there was a question at the back here. First of all, just to the side. Yes, you said.
Rob Rideout, SAT Corporation. Just a little bit of clarity on your final determination of the flight path. Am I right in thinking, did you use intersecting BTO and BFO contours, or did I misunderstand that?
Not really. Well, you have the BTO values. You have to cross over those arcs at that time, within 10 kilometres or so. So the arcs are from the BTO. The BFO just allows you to say, if I cross over the arcs at this particular location, at this particular speed, what would the BFO be? And you can compare that against what the model says. So it's 2 bits of information used, but they're not intersecting as such. You have to cross over the arcs at the right time.
There's no contours from the BFO.
I'm not sure what you mean by contours.
Well, in the same way you get contours from the BTO. You don't get
the
lines
BTO
of
gives
constant...
you they're not contours. They're a contour of constant distance from the terminal to the satellite. I showed you something like a contour map earlier where you had the northern latitude showing in the negative values and the southern latitude showing the positive value because the satellite's moving from north to south. So in a way that's also a contour. So yes, I can see where your question is coming from, and maybe the intersection of the two is a good way of thinking about it.
Okay, thanks.
Okay, and then gentleman in the purple shirt, and then behind there.
Paul Sladen again. Can I take you back to 8 o'clock on the 23rd of May, which is the morning that the redacted log file was started to be prepared? And a couple of hours later, you had the CNN interview with Richard Quest. In the redacted log file that was being prepared at 8 o'clock onwards, only 9 out of 28 columns are present, which I think is what the gentleman over there is hinting at. But in the CNN interview, you very kindly showed the unredacted log with all 28 columns, and we can see information in that such as the fuel load on takeoff and other relevant communications between parts of the aircraft to the ground. Perhaps that's the information. There's some other information that's not in there. So we saw today for the first time the gain values. That's the signal strength, which is also not in that log. Can you just perhaps follow on to the gentleman and confirm that it's not the lines that are missing, but it is the columns that are missing, the actual payload of the data? Well,
it's not the payload. It's still signaling information. It's not payload. There's nothing to payload related in there. It's signaling information. And I think an example in the release file, an example of every column is provided. This is saying that these are all the information that is available in the full log. And then these are from the subsequent rows. So you can see what information is contained in the log. And it's really up for the investigators to release what they want to. It's not for an Inmarsat. Inmarsat's just an advisor into the investigation team.
But you were very comfortable showing the unredacted log to CNN. You showed 5 pages of the raw CSV file to CNN. Those were the ones where I transcribed it and image processed it and ran the CRC16s, and basically it's like breaking a 2,000-bit key, but I recovered the messages in there.
And was there anything surprising in there?
Yeah, the fuel values, so 49.2
and I think the fuel values have been reported. Oh, okay.
No, Malaysia reported 49.1 tonnes. So there's a discontinuity there.
I think we have our logs. We've analysed the BTO and BFO values, and we provided information. The whole investigation teams had all the logs unredacted throughout the whole period. It's not an Inmarsat job to release the data.
Okay, the gentleman there.
Yeah, thank you very much. For me, I'm just looking at takeaways from the event. And part of the takeaway is, consideration for black box in the cloud. And I'm also looking at probably if we must reduce the uncertainty in precisioning of location-based, application of the satellite. I'm looking at probably when we have a precise, optimized, temperature-compensated, overnight oscillator on board the navigation transponder. This could also help in precisioning of the, in location-based services, so to speak.
Right. Well, the position reporting recommendation that we're making, which is also reflected in the recently released IATA aircraft tracking task force recommendations, is to use the ADSC position report as the near-term basis for any improvement to position reporting or the frequency of position reporting. It's widely accepted. It includes, I think, 5 parameters, including heading, speed, position, time, in terms of what the industry is already doing. And all we're talking about here is exploiting something that most airliners are equipped to deliver. Most airlines use on a routine basis. For example, if you fly in the North Atlantic, it's mandated to use that capability to get preferred routings. If you don't use that capability, you get a disadvantageous flight track across the Atlantic. It is something that is widely used, and all we're simply saying, we're trying to do as much as we can to encourage the use of that capability globally, ideally. But the true FANS ADSC capability is only implemented in certain flight information regions around the world. It was shown in one of the charts as the purple area, but there are areas where it's not implemented. But what the IATA ATTF has also recommended is that airlines themselves take responsibility for tracking their own aircraft. And what that's doing is bypassing the need for various air traffic control or air navigation service providers to upgrade or perform to various FAN standards. And as we know that a lot of aircraft operators already do, to give that same highly reliable, widely implemented ADSC FANS capability to the airliners themselves. Airliners use basic position reporting that gives them an idea of where their aircraft is. This would just synchronize everything around the same format of reporting. So in terms of location, it is already there. It doesn't need anything more in terms of a more reliable oscillator. All the position report is doing is taking navigation data from another aircraft system and downlinking it in the form of a fixed format message. So it's widely understood, and it's doing something that, as I say, has been used vastly around the world for many years. Currently on our network, actually, we have people that are using that capability to report down to every 2 minutes anyway. It's something that aircraft operators, depending on what the business model is, they'll do that anyway. On the North Atlantic, I think the reporting interval is every 18 minutes on average. Outside of the North Atlantic globally, it's every 22 minutes. So we're not talking about much in terms of improvements. And then the other thing to remember is this deviation report, that as soon as the aircraft deviates away from its filed flight plan, that also already is in place to trigger a position report to give you that position at that particular time. And again, the likes of CETA and ARINC have very sophisticated software packages and message handling solutions that allow airlines to get a whole host more out of this type of capability. And just one byproduct of it is it handles and displays position reports and allows them to more easily manage those sides of things. So again, from a flight tracking perspective, the solution already exists. It's just stimulating the much wider adoption on a global basis of that capability, and that indeed is what the IATA ATTF has done. With regard to black box in the cloud, there are very many more issues around that, and as I said in the presentation, it's less getting the data off the aircraft, it's more deciding what the trigger point would be for that. There are some other sort of, how shall I describe it? human factor related issues of increasing surveillance to flight crews and things like that. But the technology exists. It's about the business model. It's about finding the way that the industry can embrace it and deploy it very rapidly.
Okay, question here. We'll come here and then halfway back.
Hi, I'm Mike Fickard. I was interested in the data that gets downloaded. How much data gets downloaded? What is your storage capacity? How long do you retain this data for? How far back can you see? And just following on from that, you're talking about increasing your, doubling your ping rate from an hour to half an hour. Obviously, that would double the rate. What capacities do you have?
Well, it doesn't quite double the rate. It only doubles it for those terminals which aren't logging on every time. Most terminals log on, so in fact they have more data rate. This is only a scenario where the terminals doesn't log into the network for a while. The logs are large, but they're there. The logs are there for engineering purposes to manage the network. They were never intended to be used in this way. And we keep them for a long time. So actually, I was surprised how long we do keep them, or how long we can keep them for. But they are very large. We obviously keep them because questions can come up if an aircraft goes missing like this, or if there's any performance issues or anything like that. So, yeah, we keep them for a significant amount of time. I can't put a number of months on that. I can't remember off the top of my head, but it is months.
Right.
But they are large as well.
And are these disseminated out to other organisations, or is this retained within?
They're purely management logs kept in the network. If the authorities need to, like CETA or ARINC, or the distributors who have the customers' data, then they can ask for them.
Hi, Rick Lipscomb from the RAF Flight Safety Team. In the first presentation, it's not such a technical question as some of the others perhaps, but you kept referring to the terminal on board the aircraft. Now, it's widely believed that somebody on the flight deck manually deselected a lot of the comm systems. So I was just wondering what you meant by the terminal that was clearly not affected by any of this manual deselection that went on of the radios, potentially IFF and all those other systems. What exactly was the terminal?
The terminal is the SATCOM unit.
Okay.
That's simple.
And there's no means of manually deselecting that?
I'm no expert on. All I'm looking at is the data we've got. How, what, when, and stuff like that's for the investigation team, not for me. I don't know. I'm no expert in, like you are, in how aircraft work and stuff like that. All we're looking at is the data that we have, and the terminal logs back on again at 1825 or so. And you can see that in the logs.
Okay, thank you.
Okay, we've got time for one more question, and then we'll have to close. Down here, at the front.
Inmarsat's a commercial company. You've done a tremendous job by the sound of it. How much has this put an extra burden on the running of the company?
My time, quite a lot. Over the overall company, we certainly haven't been paid or would want to be paid for any of it. We're not doing it for that reason at all. For certain bits of the company, it's taken a lot of time and effort, but we're doing it for the right reasons of helping the investigation. Inmarsat's a company which has safety as its heart. It's where its roots are in maritime safety, and that's the culture throughout the company. And so when things like this happen, there's never a question about how much it's going to cost us. We've got people who just do it because it's the right thing to do. So it really is. You can really see how people were keen to try and help and bring their expertise along to try and solve this tragic situation.
I can actually say, in addition, partly because of this situation, but also it coming on the back of Air France 447, and the fact that it will stimulate more requirements for both tracking and streaming of data. So we are significantly increasing our resources to be able to support. For example, today there are 3 industry meetings going on here. If you count this as one, we have people in Washington, D.C., we have people in Montreal. So we are staffing up because there is a significant increase and interest in this area, and it is something that Inmarsat services will be used more. and we have a capability that, that can meet the industry requirements. So it has cost something to support this. It's what we do, particularly as Inmarsat's data is the only material data that can help the MH370 investigation. But we will then take more and continue to invest, given the seven-figure sum we invested in just the classic aero network, the significantly greater sum in the in the Swift broadband safety network, and it is something where we do find ourselves, having a capability that the industry can benefit from.
Okay, thank you very much for that. Thank you for all your questions. I'd now like to invite Richard Peckham to the stage to give the vote of thanks.
Thank you very much, Chris. So I'm Richard Peckham. I'm here just representing the IET's Satellite Systems and Applications Network. Now, I expect, while I found both talks fascinating, I expect, like most of you in the audience here, you saw the reports at the time. We saw Chris McLaughlin quite frequently, and I know Chris quite well, and he's definitely not an engineer. So I was really looking forward, I have to say, to hearing from an engineer kind of how it was really done in a little bit more kind of technical, gory detail. And I think somebody described it as forensics, and that really was what it was. I work with Airbus Defence and Space, formerly known as Astrium. So we built the Inmarsat 3, 4 and the AlphaSat satellites. So got kind of an interest, and obviously as part of the Airbus group, quite an interest generally in aviation. And prior to joining the space sector in 2000, I worked in air traffic management, in fact, for about 15 years, and was working on kind of FANS 1 and things. And it's obviously been very disappointing that, when so much time's moved on, that the capability that's been around for ages, just isn't being used. So it was really good, David, to hear from you. And, Inmarsat taking an initiative now to try and make sure that the technology that's been there for ages actually gets used, and we don't get in this situation again. So it's my pleasure to kind of thank you and to offer you a little bit of IET memorability, which looks very good, actually. So Mark, so thank you very much. And thank you all for coming.